Okay, good morning, good afternoon, good evening, depending on where you're watching this video from. Okay, this is module 6 of the IT Essentials version 7. So we've looked at networking. So today we're going to be looking at applied networking. So this is slide intros. Okay, it starts from here. So device to network connection. So there's a video in your LMS that gives you an explanation of how MAC addressing works. So please make sure you go through the video, the LMS, and make your notes. If you have questions, please ask on the mentorship group. And there's also a video that explains the difference between your IP version 4. I think I've said some things with respect to IP version 4, also IP version 6, difference between decimal, binary, hexadecimal, subnet max, IP address, network, and host portions. If you have 192.168.8.1 as an address, what part is for the network and what part is given to the end devices, the endpoint devices. Also for IP version 6 addressing the hexadecimal segment, the compression rules, because IP version 6 is actually very long. I told you earlier on the IP version for IP addresses, you have IP version 4 and IP version 6. But the point there is that IP version 4 is 32 bits, whereas IP version 6 is 128 bits, right? Now, IP version 4 is just four set of numbers, for instance, 192.168.8.1, separated by dots or full stops. Whereas IP version 6 is a little bit much longer. So the question is that how do we do compression? How do we compress it into a very readable format? Now, two network addresses. So this is your MAC address. So your MAC address is the fingerprint of your NIC card, right? So whereas your IP address gives you like a signature, your address. So these are two very important address when it comes to networks. So this is layer 2, this is layer 3. So IP address for IP version 4, I told you is 32 bits. It's what this is an example, 4 parts separated by footstops, whereas IP version 6 can be very, very long. It's 128 bit. This is a compressed format. So we're going to learn how you do the compression. For instance, if you have all of these zeros like this, you can compress it with just 2 dots. If you have this, you can ignore all of these things. They're all zeros and indicate with 2 dots. So 2 dots will take care of as many zeros as possible. So that's why you have after 0200 here, 02200, this goes off. Then you have 2 dots, then you have 8, this. So these 2 dots here, double dots, takes care of all of this. So these are compression techniques. You're going to learn how to do that. To network address. Now, every system is going to have both an IP version 4 address and IP version 6 address. If you want to try that, you could just get on your Windows machine or your Linux ipconfig or ifconfig. That on your command prompt, you're going to see all of this. It will tell you to show you all your network adapters and all of their MAC address and also their IP version 4 and IP version 6 address. Okay, good enough. Yes, so you have it here. ipconfig. If you say ipconfig/all, it gives you for everything, all your adapters. So this is the Ethernet adapter for this particular system. This is the name of the adapter is an Intel Pro /1000 MC network connection. This is the physical address. The physical address is also called the MAC address, right? Now, DHCP, I talked about in module 5 about DHCP, Dynamic Host Configuration Protocol. Is it enabled? Here it's saying no. IP version 4, IP version, there's no IP version. Okay, there's IP version 6 here. Yes, you have it, IP version 6. So the three addresses, we have them here: MAC address, IP address, version 4, That's this one. Okay, right now this system does not have an IP version 4 address because the IP version 4 address is going to take after the default gateway. So this is 192.168.200.1. So the default gateway or the router that is sending IP address to all of the systems through the switch or directly is going to take 1. So every other system is now going to take from 2 to up to 254, right? Okay. So this is where you enable DHCP. If you click on this, you are saying that please let it be dynamic. Give IP addresses automatically. So this is the network portion. Like I said earlier on, this is the network portion. So the default gateway is 192.168.200.1, whereas this particular system is picking 0.8. Are you there? So don't forget to say IP version 4 is 32-bit. So we have 8-bit, 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 8-bit. So 8 plus 8, 16 plus 8, I think 24, plus another 8, 32-bit. So this is the network portion, this is the host portion. You should be able to understand that. Okay, for IP version 6, there are rules in trying to reduce your IP version 6. Omit leading zeros. So if I have this IP version 6 address, for instance, I have zeros here, so I'm going to omit this. I'm going to omit all of this. I'm also going to omit this. So if it's fully expanded, for instance, you have this. If I remove any leading zero, so this becomes this. I remove this zero, it becomes this. I remove all of this zero, I just have only this. Okay, this stays. I remove all of these leading zeros, I have this. I remove all of these leading zeros, I have this. I remove all of these leading zeros, I have this. I remove this leading zero, I have this remaining. So if I compress further, I have this, I have this, I have this, I have this. All of these are zeros. I could indicate by two semicolons, and I have this. I have actually compressed. So most of the times when you do IP config, for instance, within your system, what you see is the compressed version. Either what you see is the compressed version. You don't get to see the long IP version 6 address. No, you see the compressed version. This is another example. So you have these slides, you could check through them, and if you have questions, please make sure you ask. So for static addressing, this is how you do it. You enter this particular address, you hit your tab, and you have all of this populated, and you also indicate what your default gateway is going to be. So this default gateway is normally by your router, if it's a vendor neutral router, but if it's a Cisco router or if it's a managed routers, it then means that you have to assign IP address to that particular router. And if you have assigned IP address, it's good you start with a 1 so that every other system is going to pick after that. Okay, so if you want to indicate dynamic addressing, please you make sure you use this. You indicate this. If you want to use static, you use this. So once you indicate this, dynamic host configuration protocol starts working. Okay, what's here? Link local IP version 4 and IP version 6 addressed. Okay. IP version 6 device must always have a dynamic or manually configured. So you must actually indicate whether you want it to be manual or you want it to be dynamic. So there's a packet tracer tax here. After the entire 14 modules, we're going to start working on our packet tracer and some of our case studies and hands-on. Network design. So you want to learn, how do I design my network in such a way that I'm able to have resources shared. So here, what are we sharing? We are sharing internet facilities. So this is a typical home network. Network components, network design. So you just have wireless to this router, router to a modem, the modem to an ISP. Selecting your NIC, we looked at this earlier on. So you can choose wired, If you are using this wire, that means you have to have a cable, Ethernet cable here. If you're using wireless, so it connects wirelessly, or if you're using an adapter, this is still wireless also. Okay, installing and updating your NIC. There's what to call the device manager. You could go to your adapter category, right click on the NIC properties update driver, right? So, it's always on your device manager. You could go through, hit on your Windows tab, type device manager. You're going to come to this place. You see all of the drivers that are installed for all of the hardwares, the input and output devices, from your hard disk to your display to your CD-ROM. All of these guys need drivers to work. Same thing with your wireless. So if you have a system and the wireless is not working properly, you might need to update the driver or install a new driver. But you must make sure that you have the exact driver for this particular hardware. So that's only what's going to make it work. Same thing for a mobile phone, very self-explanatory. Most of us will use mobile phones, so you see most of these settings and you can actually configure it. What do you call ICMP, Internet Control Messaging Protocol? So there are several types of messages, like your ping command, your ARP request. Once you do all of these are messages that help you to understand or learn about your network. You call them ICMP. So they are used to test connectivity and get error message back and forth. For instance, if you say ping Cisco, it's going to tell you if you have full connection to your network. If you try this out, it will send 4 packets, right? If it receives exactly 4 and lost nothing, that means you have full connectivity. For instance, if you say if you want to test for internet connectivity, you're not sure whether you're connected to the internet or not, you could just uh, you instead of testing at your application layer, at the last layer of your SEC model, you could attempt to test at your layer 2, right? At your network layer, or rather your layer 3, at your network layer, between your 2 and 3 layer, you just do a ping. So here you are isolating your application. That is just saying you are isolating your Chrome browser or your Explorer or your Safari. That might have issue. You just want to check directly if you have access. For Google, for instance, you say ping 8.8.8.8. If you get 0 loss, it then means that you actually have internet on that PC, because you can connect to the internet, you can connect to Google. So there's a lab here also. We're going to do that later on. There's a video explanation on how to configure a wired and a wireless network. So it's very self-explanatory. Take your time, go through them in your Cisco NetAccount LMS. For those of us that are watching that are already running through the training, once you signed up for the course, you could have access to the LMS. You could do all your learnings. You could take your program, take your quiz, take your modules, get your certification, and also you can get your Cisco badges. Okay, connecting wired devices to your network. So it's as simple as this. Connect the cable to the device, connect the other end to cable to the switch, then connect cable between the wireless router and the broadband modem. So this is what you have here. So connect this guy to this guy, connect this guy to this guy, and you're on the internet. Okay, most routers allow you to be able to manage them via web-based portals. Make sure you change the default authentication access for your router. You don't want to be vulnerable. Yes, change the default username and password immediately. So check at the back of your router, you will see what the default IP address is for that router and the username and password. But make sure that you connect the PC you're going to use to do this access or the mobile phone to that router. If you don't connect it, you cannot have access to this. So you connect through wirelessly or you connect via a cable. Once you do that, you're able to hit this and you're able to have access, and you could now start doing your configuration. So there are several configurations you could do on a router. So you could indicate you want to have DHCP working. You could change default IP address. You could configure some security settings. You could say access restrictions. I don't want people to browse, connect to the internet between so time and so time. You can say I don't want people to be able to use so applications or so games. You have a lot of things you could do when you have a very robust router as this. Of course, there's newer routers that can help you do a whole lot of things, right? So you can actually control access of anybody that's going to connect through this router over to the internet. And some of the settings are you indicating which band do you want to use, which encryption. Later on in the Cisco Cyber Ops training, we're going to look at most of these things in details, especially for encryption. Cryptography is a module on its own, so we're going to exhaust that uh, in that course. Okay, configure a mesh network. So we'll do all of this stuff. Same thing with this, for you to be able to see your status, if you're connected, what IP address is configured, all of these things, you have that in your settings within your router. Yes, your router can also give you indication for QoS. QoS is quality of service, right? You could prioritize different types of traffic. For instance, if somebody is using an iPhone, which kind of priority do you want to give to the person? If somebody is on Netflix, if somebody using 5 protocol, if somebody is using the DNTLR or SMTP, so you just want to, quality of assurance is what quality, what degree of preference do you give to a particular device, a particular application, a particular protocol, right? So you can actually configure all of that. You could edit it. You can say, okay, I want to give it very high. What it means is that these guys, we have higher bandwidth allocation, right? Let's say you're using 10 MB per second up and down. These guys will have more preference. And these guys will have, of course, this guy, for instance, we have, if this guy is in use, so this can get up to as much as 6, 7, 8, whereas this can just be given 1 MB per second, right? So that's quality of service. You could configure it so that what needs to have access to the internet is given access. So there's a package activity. We're going to do all of that. We're going to have separate videos altogether for packet tracer attacks. So for this, is just to give you a heads up on the video slides. DMZ, that's a demilitarized zone configuration in LAN, wireless firewall rules, universal plug and play. So that explanation is very straightforward. So when you say demilitarized zone, you're trying to say which section of your network do you want to have for items that you don't trust. For instance, if you have an office, you could have a zone where you have visitors. For a home, you can have a section where you have visitors, and you put them on that section of the network. This is also a security methodology. This is a way to ensure a secured network. Port forwarding, yes. Port forwarding allows traffic to specific ports. So you could allow some things, you could disallow some things. You have several settings. You could have mark filtering. For instance, you could use a tool like Nmap, Network Mapper. It's an open source tool. You could scan your network. You could say, this particular PC, I don't want you to have access to this network. You could block some MAC address. You could do filtering. So you need to first enable MAC filtering. Then you could add those MAC address here and you can save it. Once you save it, that guy will never have access to this router, right? You cannot have access to it. You cannot browse, no matter what you do. Of course, there are some countermeasures to that. Same thing with blacklisting, whitelisting. So whitelisting has to do with allowing. Blacklisting has to do with disallowing. For instance, if you don't want people to access Facebook within your network, most routers can help you achieve website whitelisting and blacklisting. So if you blacklist Facebook, for instance, that means that through this website or YouTube or Instagram or any of the social networking sites, that means that people within this network will not be able to access those sites, right? Same thing, timing. You could indicate the time when you want them to have access to. For instance, you can say just work hours every day, or you take Monday, Tuesday, Wednesday, Thursday, Friday, and you say 9 a.m. to 5 p.m. Anything outside that time, people will not be able to have access to this network. A nice one there. So, okay, we have a packet tracer lab, Internet of Things. Awesome topic. There's another Cisco course altogether. You might be interested in taking that. You have the IoT fundamentals. Then we also have the IoT connecting things. Then we also have the big data, Cisco data analytics. There we use Python, and we do use a Raspberry Pi and Arduino to do some very, very nice things. So anytime you hear the word Internet of Things, you're trying to say you have things, gadgets, devices like your phone, like your camera, like your car, like your TV, like your AC, like different gadgets. If you are going to control them over the internet, I have my car at home, it's a smart car, and I'm in the office and I want somebody to put something inside the boot or pick up something from the boot. With my phone here, I could launch an app and connect to that car and open up the boot. Or a camera at home, like I have a camera at home and I want to see what is happening at home, and that camera have a two-way audio. That means my kids can speak into that camera, I with a phone far away, distance and miles, kilometers away. I could speak into the camera and say, hello kids, how is everything? How far this, how far this, how far this, right? And they can speak back to me and I can actually stream. So when I can be able to control things over the internet, it then means that if you want to do that, you need robust bandwidth. You need good internet service. So that's Internet of Things. May connect a pre-existing network or a network of its own. A smart home contains IoT devices. So when you say you have a smart home, that means the curtains, maybe the TV, the gates can be all automated. It then means that you need to have good bandwidth of internet service at home so that you can control components of your home, maybe through remote control or through a very long distance over the internet. Yes, IoT devices in packet tracer. So packet tracer have quite a whole lot of devices, your solar panels. If you are doing the big data analytics course with us on via the Cisco platform, it's an awesome course. It's a nice course you want to take. So it has different, like your panel, your battery, what's this? Can't see this properly. Your AC, your fans, your several kind of things you could control over the internet. Okay. Yes, this is a packet tracer lab also. Troubleshooting. If you have to troubleshoot, what are you going to do? Just like we learned when we were doing hardware. Same thing applies to network. You first identify the problem, you establish your theory, what will be the probable cause, then you test out some of these things. Of course, you don't forget to document. So we've looked at all of these things earlier on in your previous module. Same thing applies to your network. You test, establish, then you make sure that you document. So you have some issues and what can be the possible solutions. So go through this. If you have any question, please make sure that you let me know on the mentorship group. And when it's time, we're going to be doing the packet tracer labs and the physical labs. And don't forget to check through most of the videos you have on the Cisco NetAcad learning management system. Thank you very much. I think that will be all.